Okay, so the first question here, so you're asked to graph y equals -2, x minus 1 times x plus 1, the whole thing divided by x times x minus 2. So following the procedure that I outlined in my R1 and R2, what do you identify first? The intercepts, okay? So start with the x-intercept. So to get the x-intercept, you set y to 0, right? Setting y to 0. So setting this to 0, for this to be 0, what has to be 0? The numerator or the denominator? The numerator, right? So -2, x minus 1, x plus 1 equals 0. For this to be 0, well, for this equation to be 2, either x equals +1 or -1. Okay, straight away put down the points on the graph. All right. Next, y-intercept. For y-intercept, set x to 0. Now, based on this equation, can x be 0?
No.
No, right? It's always good practice to put down the restriction for rational function. What are the restrictions here? X cannot equal to 0. X cannot equal to 2. These are the restrictions, right? So since x cannot equal to 0, you can say since x cannot equal to 0, y-intercept, the y-intercept does not exist. All right. Next, point discontinuity or hole, right? Any point discontinuity or hole or removable discontinuity, right? So remember, removable discontinuity is another name for hole or point discontinuity. So any removable discontinuity or point discontinuity. No, why not?
There's no factor.
No common factors, right? So no hole or point discontinuity. Since P of x, well, I'm calling this P of x. I'm calling this Q of x. P of x and Q of x have no common factors. Next, what's the next thing? Vertical asymptote. So the vertical asymptotes are the restrictions. So x equals 0 and x equals to 2. Okay, so put them on the graph. What's the next thing? Horizontal asymptote. Horizontal asymptote. Okay. Any horizontal asymptote?
Yeah.
Yes, right? Because the degrees of P of x is the same as the degree of Q of x, right? Okay, how do you show that? How do you find that, right? So horizontal asymptote is really the behavior of the graph as x approaches positive or negative infinity. So the function is -2x minus 1 x plus 1 divided by x times x minus 2. Okay. So what would you do? Or what do you do? So I can common factor out x from, yep.
You don't need to factor any, right? Since none of the x's have their own coefficients, which means that the coefficient of the numerator has to be -2 and the one for the denominator has some form.
Yeah, so the coefficient of this is 1, right? So intuitively, you know y equals -2 as x approaches positive negative infinity. But to show it rigorously, to show it like, you know, in a mathematically rigorous way, right? I can common factor out x from each one of these factors. So this becomes x times 1 minus 1 over x. Common factoring out x, and this gives me x times 1 plus 1 over x, right? Because when you multiply x in, you get x plus 1, right? Same thing here. And then here, well, this is already x. This I can common factor out x, give me x times 1 minus 2 over x. Okay? So now I just have to rewrite this. I have -2, which is still there. X times x is x squared. And then I'm left with 1 minus 1 over x, 1 plus 1 over x, divided by x times x is x squared. And I'm left with 1 minus 2 over x. Okay. So now I can cancel out x squared from numerator and denominator. And I'm left with the limit of -2 times 1 minus 1 over x, 1 plus 1 over x, divided by 1 minus 2 over x. So the next thing you write, you can drop the limits notation, because the next thing you write, you're going to see how this actually behaves as x goes to a really, really large number. So what happens to 1 over x as x goes really, really large? -2 is still there. So this thing will be approaching 0. It might as well be 0, right? Same thing here. 1 plus 0. This is 1 minus 2 divided by a really large number is still 0. Okay, so this essentially becomes 0. This essentially becomes 0. This essentially becomes 0. So what is this? 2 times 1 times 1 divided by 1 and -2 is -2, right? So the horizontal asymptote has the equation y equals. You show it rigorously. Yep.
Does it matter if you do it as x approaches positive?
It doesn't matter. Yeah. But if you were to just do one, show the positive infinity. Yeah. Okay, so now, so what's the next one? Any oblique asymptote.
No.
Oblique asymptote does not exist. Why? Because there's already one or the other, right? And number 6, crossover. Your boundary analysis. Crossover. How do I determine the crossover? Crossover of what? Yeah. Yeah. So the graph itself and the horizontal asymptote. Okay, so because the graph cannot cross what? The vertical asymptote, right? Crossover. So what do you do to determine the crossover? Equation, right? Set the equation of the original function to the equation of the oblique asymptote. -2 dividing -2 on both sides, give me that, and multiplying both sides by x times x minus 2. Oops. I get, so this will be gone. And now I can distribute that. That is just difference of squares. And then the right side is just x squared minus 2x. Subtracting x squared from both sides gives me -1 equals -2x. Solving for x, give me an x value of 1/2, right? 1/2. So It is. This is 1/2, so right here, that's the point of intersection between the horizontal asymptote and the curve. Now, do you need to do any limit analysis for the boundary analysis? You know the pattern now, right? So you don't really need to do any more limit analysis. I know this has to go like this. Why? Why can't it be the other way? First of all, it cannot go like that, right? Then it won't be a function, right? But if it goes it won't. That's right. Yeah. So on this side, well, I know he has to cross here. Does it cross the horizontal asymptote? No, right? That's the only point in the section. Okay. And on this side, in this region, is it A or is it B? Otherwise, I'll have another x-intercept, right? So it has to be like this. And it doesn't cross the horizontal asymptote again, right? Because that is the only point of intersection between the graph and the horizontal asymptote. Okay. So yeah, that's it. This you don't really need to do any limits. Okay. All right, so how do we grade this? This is 1. No, that 1. 1. 1, 1, 1, 2, 3, 4, and then 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and then the graph itself, each region give 1 mark. 10. So this will be out of 10. Right? Each region, each correct region gives, yeah. Well, this is the reverse. You're given a graph, right? And a single description here, HA, which stands for horizontal asymptote, and it has an equation of y equals 1. Write the function. So let f of x be the rational function. Okay. So based on the graph, right? What can you tell from the graph? The x-intercepts, the vertical asymptote, well, and then the horizontal asymptote. So based on the graph, you know, knowing the x-intercept gives us the what? The factor of the numerator, right? The factors of the numerator. Oops, +1, -1. And then based on the vertical asymptote, we know the equation, well, the factors of the denominator. So what are the, so x equals 0, so that is associated with this factor for the numerator, denominator, and this is x minus 2. Right? And then what's missing? We still have a coefficient a, right? We still have a coefficient a. So what is a associated with? The horizontal asymptote. So we know that the horizontal asymptote is defined as y equals the limit as x approaching positive infinity of a, the function. Okay. Now let's manipulate this A stays the same. So what am I gonna do? I'm gonna common factor out x to give me x times 1 minus 1 over x. This I'm gonna do the same. X times 1 plus 1 over x. This is already x. This I'm gonna common factor out x to give me x times 1 minus 2 over x. Okay, so the numerator is x times x is x squared. And I have 1 minus 1 over x times 1 plus 1 over x divided by x times x is x squared. 1 minus 2 over x. Okay, x squared and x squared cancel. I'm left with a times 1 minus 1 over x, 1 plus 1 over x divided by 1 minus 2 over x. Okay, so now this point, I can drop the limit notation to give me a times 1 minus 0, 1 plus 0 over 1 minus 0. So that is just a. Okay. But we are given that the HA is y equals 1. So y equals a, y equals 1. So a equals so a equals 1. Right? A equals a. Hence, f of x equals 1 times x minus 1, x plus 1, x times x minus 2, as needed. Okay, so how should we allocate marks? Each one of this is 1, 1, 1, 1, and then this 2. Okay, the 1, 2, 3, 4, 5, 6. This is out of 6. Out of 6. Okay, please mark this up accordingly.